to start a new topic in physics, which is going to be a quite vital topic for you, as it is the basis of whole mechanics which you are further going to study. So the name of the topic is center of mass. Let's start it. So let's start by defining what is center of mass. What do you understand by saying the term by the term center of mass? So is it does that looks like the geometric center of a body? Yeah, but for many cases it is not going to be the geometric center of the body, and the center of mass of a body can lie outside the body also, or the center of mass is not only defined for a single body only, it can be defined for multiple body system or multiple particle system, as we can say. So what is center of mass? Center of mass is that particular point about which we can analyze the motion of a system of particles. So general motion of system is studied by replacing a system by a particle located at its center of mass. Motion of center of mass is the general motion of system. So now for example, when you throw a stick in the air, there is a particular point in the stick which follows all the laws or all the conditions that should be followed in a projectile motion. Not all the points on the stick are following that. The stick may be revolving like that. The stick is going to be like that, but there will be a single point which is following all the possibilities of the of the projectile motion. So let's suppose this. So when you are throwing a body from here, and so it may go like this, 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 from here to here. But there is a particular point in that body which, let's suppose that point is this. This point is supposed to be the center of mass. This is particularly following the old trajectory of projectile motion. This is the particular point which is going on a parabola. So this is basically following projectile motion. Okay, so now I think you have a basic understanding of what center of mass is. Now we will start with how to calculate center of mass. For that, we can take a system of particles, system of multiple particles. Let's say this is our x, y, z coordinate, or x, y coordinate system, and there are multiple point particles, or for initial case 2-point particles. Here these are m1 and m2, and m1 is at x1, y1, and similarly m2 is at x2, y2. Then this particular two system particle has center of mass like that the x center of mass, that the x coordinate of center of mass can be written to be m1 x1 plus m2 x2 divided by m1 plus m2. Similarly, the y coordinate of the center of mass can be written to be equal to m1 y1 plus m2 y2 divided by m1 plus m2. So this can be generalized for n number of particles. So for that generalization, if let us suppose that if there are m1, m2, m3, m4, mn particles at r1 vector, r2 vector, r3 vector, r4 vector, or rn vector. So the center of mass for this system of particles can be said to be at rcum, that is the position of center of mass where it should be. So for this can be shown to be summation of mi vector divided by summation of mi from I equal to 1 to n, I equal to 1 to n. Or it can be said that x center of mass can be said to be mixi, I equal to 1 to n divided by summation mi, I equal to 1 to n. Similarly, y center of mass can be said to be summation of I equal to 1 to n mi yi divided by summation of I equal to 1 to n summation mi. And similarly, it can be written for z center of mass. Okay, now for our problem's sake, let's do one simple problem, and then we will move forward towards one more concept, and then we will discuss one typical problem on that. Okay, so for a simpler case, for the example that we have written here, that let us suppose that on xy coordinate there are three particles m1, m2, m3. Let us suppose that they are placed at 1, 2, 3, 1, okay, no. Let's take it to be 1, 2, 3, and 4, 5, 6. For this particular system of particles, let us find out what is center of mass. So that is going to be simple. I think x center of mass equal to m1 and m2 and m3's values. m1 is, let's suppose it is 3, m2 is, let's suppose 4, m3 is, let's suppose 5 in kgs. So x center of mass comes out to be 3 into 1 plus 3 into 1, similarly plus 4 into 2 plus 5 into 3. Are you understanding what I am writing here? This is basically summation mixi. So m1 is 3, x1 is 1, m2 is 4, and x2 is 2. Similarly, m3 is 5 and x3 is 3 divided by summation of mass. So summation of mass comes out to be 3 plus 4 plus 5. So the x center of mass can be written to be 3 plus 8 plus 15. So 8 plus 3 is 11. 11 plus 15 is 26. It can be written to be 26 divided by 5 plus 4 plus 3, which is 9 plus 3, which is 12, which is again 13 upon 6. This is the x coordinate for our center of mass. Then we have a y coordinate. For y coordinate, similarly, we can write m1 which is 3 into y1 plus m2. m2 is 4. m2 is 4 into 5, which is y2 plus m3. m3 is 5. m3 is 5 into 4, which is y3 divided by 3 plus 4 plus 5, which comes out to be 18 plus 20. 18 plus 20 is 38. 38 plus 20 is 58. So we can write it to be 58 divided by 5 plus 4 plus 3, which is again 12. So here which comes out to be 29 by 3. So basically center of mass lies at, our center of mass can be written to be 13 by 6 and 29 by 6. 29 by 6. Thank you for correcting me. 29 by 29 by 6. So this was a simple problem, and for our next case we are going to discuss another concept. Now we are going to discuss a concept which is not real. That concept is we use for our sake to solve the problems. And the problems can are maybe 3D, but mostly they are in 1D or 2D. So for we are discussing about density here. Actually, density is not a concept in 1D or 2D, because the world is in 3D. So density also comes out to be in 3D. But in 1D motion, in one dimensional, for one dimension, we can define the one dimensional density. Let's see how can we define one dimensional density. So for one dimensional density, let's suppose that we have this particular thing in one dimension. So, and we are, how can we find the density here, or how do we define the density here? In one dimension, this is in one dimension only, but we can still choose a length dl over here, dl, and the mass of this particular thing can be said to be dm. This is one dimensional mass, and this, so the density in one dimension we define as lambda equal to dm by dl. Understood? Similarly, in 2D, in two-dimensional density, we can get that there for a particular 2D object we have a particular dA. dA is area, is a small area over here, and let's suppose it's 2D mass to be dm. So density in 2D, and then we call the density in 2D to be sigma. So sigma can be written as dm by dA over here. And similarly in 3D, this is the real density over here. We have a volume having we have a small volume dV, and its mass is dm. So the density comes out to be, this is real density actually, dm by dV. So these two are things that we define for our sake, for our problem solving sake. So now let's solve a small problem in 2D. So let's suppose that we have let's let's suppose that we have a semicircular ring in our 2D. Okay, so this particular thing is a semicircular ring placed over here, and the we for our sake we take theta and we say that at any given theta the two-dimensional density for this particular ring is lambda equal to lambda naught sine theta. Then we need to calculate the center of mass of this particular semicircular ring. So let's see how we will do that. So let's suppose that this is our coordinate system. X, y, and theta is like this. So at any given theta, we can take a small length over there. Let's suppose that the small length over here is dl, and dl is represented by d theta. So we can write that dl equal to r into d theta, as this is r. For dm, we can go with sigma into dl, dm, as sigma equal to dm by dl we have discussed over here. So sigma is sigma, okay, lambda into dm by dl. Okay, so this is lambda naught sin theta into r d theta is our dm, and furthermore we can define the coordinate of this particular dm over here, as we can break down this thing into this is r sin theta, r cos theta. This is r cos theta, and this is r sin theta. So the x coordinate comes out to be, the coordinate of this point is r cos theta, comma r sin theta. So this is particularly the coordinate. So if we go for finding the center of mass for this ring, it comes out to be, so basically summation of dm into for x coordinate of the center of mass, we have dm into r cos theta divided by summation of dm, and for y coordinate of center of mass, we have dm into r sin theta divided by summation of dm. Okay, and but we know that these two things should be integration, as we are taking things to be infinitesimally small. So we can replace this by integration sign, and the particular variable over here is theta. So theta is varying from this is 0 and 0 to pi. So we can take things to 0 to pi, 0 to pi. Similarly here dm, for dm also this is 0 to pi and 0 to pi. So the x center for now we can write over here. So x center of mass equal to integration of dm. What was our dm? Dm was our lambda naught sin theta. So lambda naught sin theta into r d theta into r cos theta divided by 0 to pi lambda naught, what is 0 to pi lambda naught sin theta into r d theta. Let's, so This can be said to be which is equal to r square lambda naught sin theta cos theta. So it should be sin 2 theta by 2 and d theta lambda naught integration 0 to pi divided by 0 to pi lambda naught sin theta r d theta. Basically I have done nothing but just rearrange the terms here over here, and I have written sin theta into cos theta. I have multiplied 1 2 over here and divided by 2. So 2 sin theta cos theta becomes sin 2 theta, and that is basically divided by 2, and for denominator this is this. So now exponent comes out to be lambda naught by 2. Oh, lambda naught, I have written 2 times. Lambda naught by 2 r square into sin 2 theta. Sin 2 theta integration is minus cos 2 theta. Minus cos 2 theta. So minus cos 2 theta. Theta is from 0 to pi, and in denominator also we can write it to be lambda naught r integration of sin theta integration minus cos theta. अच्छा minus cos 2 theta, so we have to multiply 1 2 over here also, और for lambda naught r, and then sin theta integration is minus cos theta, and so this also varies from 0 to pi. So for this term cos 2 pi equal to cos 0, so I think that this term is 0, and for the, so if this term gets 0, so as center of mass is at 0. So basically x center of mass lies somewhere on this line. Where does it lie? Where y center of mass will lie. So let's calculate the y center of mass now. For y center of mass, again from here we are writing y center of mass equal to from 0 to pi dm. What is our dm? Dm is lambda naught sin theta, r I am writing over here, d theta I would write at last. So basically into r sin theta, into r sin theta. So one more r sin theta. So r we can write r square and sin square theta, and we have d theta over here, divided by 0 to pi dm was again lambda naught r sin theta d theta. Okay, so now we have to calculate this integral. One integral is of sin square d theta, and one integral is of sin theta, so sin square d theta. So from here we can say 1 minus 2 sin square theta equal to cos theta cos 2 theta. Yeah, 1 minus 2 sin square theta is cos 2 theta. So 1 minus cos 2 theta divided by 2 equal to sin square theta. We can replace this thing over here in place of sin square theta, and then again I am doing the integral of this thing over here only. So 1 minus cos 2 theta by 2 integral 0 to pi d theta. So this is theta by 2 minus cos theta integration, cos 2 theta theta or cos 2 theta integration is sin theta cos theta. So sin 2 theta by 2 0 to pi. So this comes out to be half of pi minus again sin 0 and sin 2 pi are equal. So this terms basically becomes 0 by pi minus 0 is pi by 2. So now this integral comes out to be pi by 2 on 0 to pi. So this is lambda naught r square pi upon 2 divided by this is another integral. So basically lambda naught r sin theta integration 0 to pi sin theta integration 0 to pi is minus cos theta and minus cos theta is 1 minus minus 1 which is basically 2 lambda naught. So lambda naught gets cancelled, r gets cancelled, which is pi r by 4. So this is y center of mass, pi r by 4. This is an important result, you should remember it. That's all for today's session and let's end it.
Thank you.